Hey y'all. So these are gonna be my video notes for learning how to be a game developer. And, you know, if you can't read it, it says, hey listen, in big old letters. You can read that part. This is the eye exam. If you are new to the programming language Ruby, then you may find the following code a bit overwhelming. Come back to this file when you have a better grasp of Ruby and Game Toolkit. So, I was looking through my itch stuff, and one of the bundles I had bought had this with it. And, you know, I think that's pretty cool, because I've been on a journey of trying to make a video game. I want to make a creature collector that will kill Pokemon. Is that ridiculous? Yes. Is it going to be fun? Yes. I've been trying to do a little bit of programming, but it's really hard. But I'm looking at all these documentations for DragonRuby, and I'm like, damn, you know, this is looking a little bit legible to my brain right now. This is goated. What the hell? There's so much to dig into. I'm like, wait, what? I was told to read the book, so I guess we're reading the book, but there's all these tutorials in here. Launch the DragonRuby file. That's fine. This isn't a game yet, but it's doing key 3 things. Launching an app window, rendering text, displaying a rotating image. And you haven't even written any code yet. Not a bad starting place. You know what? That's so true. DRGTK handles the boring stuff when it comes to making games, dealing with the low-level APIs like graphics, sounds, and game window. We can instead focus on creating our game instead of, for example, figuring out how to save data in a way that's compatible with Linux, Mac, Windows, Android. Whoa. Wow. Okay. There's just more text. I think I have more text. Did you... I'm immediately thrown off guard. This defines a method called tick, and it passes in a parameter called args. Args is short for arguments and is provided to us by DragonRuby GTK. Methods are reusable pieces of code that you can call to do something over and over again. Think of methods like verbs. They do actions. Methods are foundational building block that allows for code reuse. They say you wanted to give a friend a cookie. You define a method called giveCookie. Pass it to the... I might be a little bit lost immediately. It's pretty intuitive once you get the hang of it. Like, I felt like I understood it a little bit more before, and now I'm like staying up late, and my brain is like, wait, how do you do this again? And I'm like, no, you know how to do this. This is real facts. I know how to code it a little bit. Not like a lot, not like a helpful amount, just like I know what a string and a float and an integer and a boolean is. I can read what this text means. Kind of. Remember, args from above, yeah, the argument. The parameter that's passed into tick. Well, you can call methods on it. Args has a method called outputs that represents the data that gets rendered on screen. Mixes it with args output. Neato. Labels is a method of output. See how the dot chains things together? Oh. Rendered on... Oh, that's handy! Yes. Is called the shovel operator. It lets you push data into a collection. Labels is the collection we're shoving data into because we want to render some text. And then finally the code with the brackets is an array of data that represents what we want to display on screen. It may not be clear exactly what it's doing yet, but it'll become more clear over time. I think of arrays like a stack of CDs. The CDs are in a specific order, but you don't know what a given CD is unless you pull one out of the stack and look at it. You have to do the same thing with an array. In programming, you put data into an array to collect the data and keep track of it. Wait, no! Oh my god! Data organization is just really complicated stacking. Oh my god. What? It's like, hey bro, I'm the most organizational stacker. You'll never beat me at organizing data in a stack. That's just what computers are? They just stack data really efficiently and then we can recall that data for later? That's kind of crazy. You can see some code in quotes. Those are strings. They have what's being displayed by the game. In order to show text, though, we need to tell the engine where to place it on screen. That's where the first two elements of the array do. There are specific X and Y positions of the text in the game. Then there's text we want to render. That's followed by the text size. Then finally, the alignment centered in cases. Here's it broken down. Hello world. Oh. Okay, I'll just get used to that. That's fine. Hey, that's handy. I love that it's all in one line. It's just unconventional, but damn is it convenient. Like, that would be... This would normally be like 1, 2, 3, and 4 maybe lines of code that I would come up with, like if I did it the conventional way instead of literally using a game engine to literally help me along. Like, come on. This is goofy. This is awesome. Don't worry about memorizing what the positional elements of the array mean. This is just a quick way to render text. We'll use a more friendly approach soon enough. The sample game does this 3 times, thus rendering 3 different pieces of text. The Y coordinate is different. Hang on, I am gonna try something really fast. I'm gonna close this. I'm gonna open this. I'm gonna do main. Yeah, this is like weirdly longer than the example given. I think. This is awesome. This is cool. Computers are cool. Like, come on. Come on, they're just so cool. Hello. Dragon. I should have had it on screen so we could have seen it. Damn it. Oh, fuck. What did I do? Hello, Dragon. Oh my god, it changed. We did it. Oh, fuck. What happened? Why did everything shut down? I mean, it didn't, like, shut down. It just, like, stopped. It, like, it minimized everything. I didn't mean to do that. Look at this. Oh my god, we're gaming. Holy fuck. Did you see that? The game reloaded your code and changed the text to Hello Dragon. That was quick, wasn't it? That's one of the best parts of DRGTK, live reloading of your game code in the engine. This allows you to make changes to your game quickly, reducing time between cycles of writing your code and testing it. Flexing when they've already bought in. Lamau. Arguments output sprites is like arguments outputs labels, but instead of holding labels, it's a collection of sprites. It renders DragonRuby PNG image at this location, just like label text, and it also sets the size of the image to display. That's what W and H represent. Finally, it rotates the image passing argument state tick count to angle. Don't worry about tick count for now. Just know that we need to be updating angle so we can see the image rotating, and tick count is convenient as it keeps incrementing for us. I need a third monitor. I'm like, oh geez, I don't have enough screen real estate for all this. Let me take a look at the code really fast. So, if inputs keyboard left, down. Oh, this is left and right, this is up and down. I see. And then argument state logo react X. I think this just rotates it. Oh, labels. Wait, no, these are just text. This is just text. Output sprites. This is what. Yeah, logo rect. I don't remember what rect means. To count. Yeah, I think this is what's causing the thing to spin around, which is good. I just don't understand what this part means. 1280, 720 would be the upper right. Note this varies from most game engines, libraries, and tools, but it's intentional to make it easier to think about gravity and following geometric 2D plane that is taught in mathematics. It's important to keep coordinates in mind, and as we'll be using them a lot when making our game. A major aspect of games is moving things around on screen, which we do by changing their coordinates. Back to making the game. Okay, yeah, you changed a string that chain and it changed what it displayed. That's neat, but let's hit reset and do it ourselves. I want you to delete the code in my game. Select it all and delete it. Gotcha. No need to tell me twice, I love doing that shit. Boop. I hit backspace, not delete, I'm sorry. DragonRuby. Oh ho ho, we have a blank screen. Trolley dolly da. I know that blank canvas is a challenge, but you need to start writing the code yourself in order to learn, so go ahead and type out each line below. You know what? Fuck it. For my own sake, I'm putting this over here so I can watch it update as I'm typing, even though I'm looking over here, and I think that's fine with the... I'm looking over here. Yeah, that's fine. And it would be against the spirit to copy and paste it, you fools. So I am just going to type it out like a good woman would. You know what this does, right? Well, you saw it automatically reload your game, so of course you do. No, it literally didn't. It's still... Fuck. Why does it do that? I don't mean to close literally all of my fucking tabs, but I'm sorry, but it does not do that. Runs. Is it because I'm doing something wrong? Oh wait, no, there it is. I was a fool this whole time. Methods in Ruby return a value. Return values can then be used by the caller for whatever purposes are needed. In the example above, the return value is a string we built. The Ruby returns a value of the last line of the method definition automatically, but you can explicitly return early with return, which can be useful if you want to end the execution of a method early. Let's wrap up this chapter by displaying a sprite. Oh my god, we did it! Game loop explained. There's a game loop in this game engine? Holy fuck. There's a lot of magic that comes from Ruby Game Toolkit, where we just write def tick and magically have a game. What's happening is that DragonRuby Game Toolkit takes code in my app, main RB, finds the tick method, and runs a loop that calls it 60 times every second until the program closes. This loop is referred to as the game loop. When programming games, any number of things are happening at one time. Enemies are moving, images are being displayed, math is being calculated, input is handled, etc. The loop runs over and over again, accounting for any changes in the state of the game. This is similar to how screens on devices work. They refresh so many times a second so fast that it's barely perceptible to the human eye. Within the game loop, we'll keep track of everything that's happening, update state, and render text and images. It's important to begin to think about things in a loop, as it influences timing and code structure. Indeed. Cyclical, if you will. The game loop will begin to feel more natural over time, but for now, remember this. DRGTK runs the tick method 60 times every second. If you're familiar with games, you may know frames per second. That's how many frames are rendered in a given second. 60 FPS is known for its smoothness and is often the target of many games. In DragonRuby GTK, the 60 ticks per second can be thought of as the same as your game running 60 frames per second. Interesting. Game loop. Check inputs, upsees the world, plays any sound, renders the graphics. So basically it goes into this pipeline, but the pipeline is a type chart, and the type chart starts with check input, update world, play any sounds, render graphics, check input, update world. So we just gotta keep track of our order of shit. The last chapter, we got a dragon sprite to show up on screen and some text. Let's build upon it by making so we can control the dragon with our keyboard and a gamepad. Because guess what? That dragon is now the main character of this game we're building. Woo! Buckle up, it's dragon flying time. Oh, I see what they're saying. I see what they want me to write. I see what they want me to write. I see what they want me to write. I see what they want, I think, I hope. Oh no, what did we do? We spelled it wrong. We did it. We fixed it. Wait, does that mean we can move it around? No. Let's start with arg state. There's a couple of new things. arg.state and 2 beanpoles with an equal sign. Let's start with arg.state. It's basically a blob that can be anything you want it to be. Wow. A bit like Kirby. Feed it player X and it keeps track of it. Whatever you feed the arg.state, it'll be accessible in future ticks. Keeping track of the game state across ticks is important. It's part of the game loop. If we don't know where the player last was, how can we calculate where they should move to? We need to keep track of it someplace. args.state is a fine place to start. What the heck is this 2 beanpole situation anyway? Well, maybe we need to start with equals. You might read that as equals, which I did, and you clocked me for that, so that means I'm wrong. But it's actually the assignment operator. It means set that thing on the left to the value on the right. It's a core programming concept. It's useful for assigning data to properties that we want to keep track of. Name is, the thing on the left means the thing on the right. That's what equals means. It equals, that's fucked up. Equals just means the thing on the left means the thing on the right. I don't enjoy it. Oh. It's not equals anymore. It's thing on the left means thing on the right. Because we're a computer and we're reading it line by line. Name equals Francis. Thing on the left means thing on the right. That code assigns the string Francis to the variable name. Then we use name to refer to that value. It may not seem quite useful yet, but soon enough. You could then use that variable like this, puts name. That calls the puts method and passes over our variable name to it as a parameter. It prints whatever the value is out of the console. If you put that in your tick method and press tilde to open the console, you'll print Francis a bunch. Huh? Do I want to do that? Wow, that was a lot of explanation for 2 measly lines of code. But I'm telling you, they're 2 really important lines of code when it comes to game programming. That's awesome. In hashtag tick, hashtag name is Ruby shorthand for the name method. We'll check to see if a given input is pressed. If it is, we'll change the sprite's X and Y position accordingly. Our old buddy args has a little something known as args input. Let us check inputs. Isn't programming nice? Most of the time, the words used in programming make sense, but some of the time they really don't. And it's a gosh darn nightmare. Let's commit right here, right now, to trying to name things in a way that's useful. Okay, you're committed. When you name a method def thingy, you'll remember this, and your ears will ring a little bit, and your eyes will get just a little dry, and you'll remember that you broke your commitment. Jeez. Look, I already name things helpfully, okay? I try not to forget shit. Oh, this is what was in it before. So let's put it in. Check it. We broke it. That is quite shocking, to say the least. I forgot one S in my code, and it's like, the whole thing's broken. I don't know what to tell you. I'm so sorry. And I'm like, no, I'm sorry. Jesus Christ. I'll be more careful next time. Anyway, hey, we made a little dragonfly around on screen. That's pretty exciting. What did I do? Where did our dragon buddy go? Oh, you know what? We didn't set a barrier or anything. Hang on. I know what to do. Okay, there he is. But yeah, he can just keep going up. There's no fucking walls in this house, I guess. Oh yeah, I wanted to try my controller. Holy fuck, it works with my controller. Okay, that's awesome. One line of code to be like, yeah, this controls all your devices from all your devices. That's like, what the fuck? Pretty neat. It's almost fun, and it was like 10 lines of code. Let's break them down. This section checks for horizontal movement. If left input is pressed, reduce the player's X position by 10 pixels, which is the minus equals. Put the left on the right. Means subtract the value on the right from the value on the left. This is the same as argument state player X, argument state player X minus 10, but it's much more concise. We increase player X to move right and decrease it to move it left. If and else if are conditional checks. The code only runs the value is true, more specifically truth E, but let's not worry about that yet. Then when we check the vertical movement, we add player Y to move up and decrease it to move down. If we want a dragon to move faster though, we could change it to 10 to 12. That's annoying to update all over. Let's make it a variable. We call it speed. Holy fuck. Okay. Oh my god, that's huge, dude. Fucking ginormous. Wow. It still is doing the same thing over and over again. Which is good. Does what we're expecting it to. You can move your dragon completely off the screen. Lost in the great unknown. This isn't ideal. Let's make it so our little buddy can't leave the bounds of the screen. Keep him trapped. Shit. What did I do wrong? Error. Missing on class. The method named blank. Remember. Player Y. Is that what I typed? I sure did. Wow, it sure did fix everything when I don't make typos in my code. We move the width and height of the player into variables so that they're easier to reference and reuse. Boom. We need those to do the same math on boundaries too. There's a general programming idea out there known as don't repeat yourself, try. As soon as you have a piece of code, especially a number that represents a value and is used multiple times, put it in a variable. This makes its intent clear as to what it represents and makes it easier to change movement. Do we want to fix his move speed? Do we want to fix his move speed? I kind of don't care. But I want to. No, I don't. Extra credit.